So, we're going to talk about Git. So Git is a version control system. Most of you are already going to be familiar with it. And GitHub is a public web interface and host for Git repositories. So it's amazing to me how many people. What's wrong here? Nope. So it's amazing to me how many people get those confused. So GitHub is a web hosting and place to share Git repositories. Git is decentralized. So like I can create a Git repository on my machine and I can sync it with you on a thumb drive. I can do it over all kinds of different network protocols, HTTPS. Git has its own protocol, which is very insecure. Don't use it. I can do it over SSH. All of these are methods where I can connect to other Git repositories and we can sync our data. But you know, and the power of Git is, it's in fact decentralized. So I can clone the repository, go on an airplane, and have the full history right there on my local machine. I can make changes, and the next time I can commit those and merge data, and the next time I'm got a connection, I can push those back up to the server and merge it with any changes up there. This may not, you may be like, yeah, right, that's just how version control works. Not always how it works. Before Git and GitHub, to make changes to a repository required a live connection. That's kind of not a fun scenario. So Git is very different in that regard. But almost most development around Git centers around GitHub or one of the other hosting providers, GitLab, Bitbucket, those are other. But GitHub is by far the most popular. So they happen to give me free unlimited private repos to teach the class from. They like you all learning about their software and actually enjoying using it. So we're going to base it off here. What I want to talk about is more of the life cycle of open source software and how you would contribute and work with Git and GitHub through cloning, forking, committing, pushing, merging, pull requests. So these are all the concepts from GitHub, from Git and GitHub. Pull requests can be done without GitHub, but they're pretty much always done with Git through GitHub. But this can get really confusing. So I'm going to show you the full methodology, and then we're going to talk about how you're going to use it in class, which is a simplified version of this. There's a couple of big steps that you get to cut out. So the first thing it wants to do is I have found a piece of open source software, or perhaps I'm working on a project with a team at a organization based off a GitHub repo, and I want to make changes. So typically when I'm going to make changes, I don't own the code or have write access. So I can't push up changes. Let's say this. Most of the open source repositories I work with, I don't have rights to make changes directly to. But I can see it and I can fork it, and then I can make changes too. So the first step on any process like this is to fork a repository. Now, you probably won't see this screen. Well, actually, you will start. No, you will. When you fork a repo, you have to be a member of more than one organization to see this. Otherwise, it just forks it to you. But I'm going to fork it to my own personal GitHub account. Now, this is really important in that, and I don't know, can someone see if you can turn off one of the lights? Middle rows. Beautiful, thank you. You'll notice up here, it says forked from, and it has a link to it. So I could have gone to the original location and cloned it down on my machine, created a repo of the same name on my personal, and then pushed it up there. I would have all the same functionality, would look exactly like this, exact same commit references and all of that, but this connection up here means making pull requests wouldn't be able to happen because GitHub wouldn't know that those two are related. So I always want to fork it from GitHub first. So here we go. So we have the Webpack starter template. This is not very interesting repository because it only has one commit. But let's say we want to fix that. I'm going to clone this repository. Now, when you first start using GitHub, it's going to give you URLs that start with HTTPS. This is all fine and dandy, unless you have two-factor authentication turned on your GitHub account, which I do. So when you do that, then all of a sudden you have to start working with API tokens and things like that to get access to the repo. So instead, what I have done is under settings, I can go upload my personal SSH key here. And now I connect to Git via SSH. And so I never get asked for passwords. I mean, that key is, I mean, it's full access to my GitHub account. So I treat it like a password. But at the command line, I don't have to retype passwords. You may want to set that up. If you're working on lab machines or working around, that may be more hassle than it's worth. But just to let you know, it's down there. For those of you really interested, you can also sign commit. And it'll check with the public key, public-private key. You upload your public key to GitHub, and when you sign it with your private key and push it, it will have a verified box around the commit that says you actually made the commit, or at least the person's key here was used to sign the commit. So there's some authenticity checks there, but that's kind of on profile. And if we go look at, did I sign this? Yeah, that verified box says I signed it. It's not the end of the world, but doesn't. A lot of people have commits up here that don't, but that's how that works. So we want to clone this down to the local machine so I can do something. So you need to clone it with the protocol you've got set up. Now, I could do all this at the command line, but most people look at me. Actually, most junior engineers look at me and think I've just told them to cheat. I prefer a GUI file to do. Why? It gets really complicated, and it's just easier to be able to visualize the graph. There are command line tools to help kind of do text displays of that diff graph and how that branching graph. They're just nowhere near nice. On simple repositories like we're going to be looking at, it's no big deal. Here's a repository that like my entire team works off of. I don't know if I can make things better. These are all branches I have set up, and you can see down here all of these dots are individual commits by different developers, and you can see how much work and how much branching and merging and reconnect. So trying to visualize how your branch compares to any other branch on there with that type of scale is just super hard. And even concepts like I need to merge. So it's really important when you do that, which branch you're merging into where. And you can get those backwards. So I just don't waste a lot of time thinking about that. And I just use a graphic client. There are several out there. My personal favorite, and the one that I find works overall and has the best feature set, is called SourceTree, and it's made by Atlassian, who makes Bitbucket, but it works with GitHub just fine, as well as pretty much any other Git repository. So that's the one I recommend. It's linked off the project server, and that's what I'm going to be showing around in class. Everything I can do here and more I can do from the command line. But we're going to do it here. So the first thing I want to do is I want to clone a new repository. Clone from URL. Paste in. Now, here's the thing. I already have one called Git Webpack Starter template on my local machine, so I can't put it in the same folder. So we'll just put a 2 on the end. And clone. That doesn't take very long. I only had one commit. Really not that big of a deal. Not much of a treat. It's a dot. So we started on our class's organization, my repo, and I forked it over to mine. It's going to be hard to explain. And now I cloned my fork down to my local machine. Okay? So I'm going to make changes, and then I'm going to push it back up here, and then I'm going to create a pull request back to the original. So we have 3 copies of this same repo in play right now. This is important to keep in your head. So here we go. Let's just go open up an editor and do something stupid. So I'm just going to add a comment that says, this is the main config. Not a very useful comment, but to start. So if I go back here, I immediately notice a few things. One, I have a new dot up here that's gray. And if I click on it, I can see down here I have unstaged files, and it has the file. And then over here I have the diff. One note, now have 2 hunks of data. One advantage to a graphical client, I could add this hunk to the stage without adding the other one. That's really hard to do with command line, but just press of a button. And now I can commit these in separate commits or do different things with them, so I don't have to commit that. So that's just one example. In this case, let's just add everything. Committing. A couple things to note. Pay attention to what email address you're committing. Now, you have a global Git config on your machine. You can set up. It's really easy to Google on how to do that. Or if you're in a graphical client like SourceTree, we can go to Preferences and check the box that says Allow SourceTree to modify the config and set it up. So when you commit, this is who you're committing as. Like if you commit with someone else's email address, you just gave them credit for work. Now, you push that through your GitHub account. GitHub is going to tell everyone that you pushed some other person's commit. Or at least it looks like you did. So GitHub does call this out, but just keep in mind how that works. And then what I type in the commit message, one thing, especially as you go through more and more complex assignments in this class, is I don't need to say what I did. Added a comment is not why a good commit message. Why did I do it? That's what I want to put there. The what is already written in the code. I want to talk about the why. So, clarified that this is the main config. We might have others later. One thing to note, signing commits in here. I have to have GPT installed on my machine, and there's a preferencing source tree, and then I just have to say, yep, on this repository I want to sign commits. So now I can go down here and just say sign commit. And commit. All right. So now we're going on. Now you'll notice some things. I have 3 branch pointer references over here. I can have way more than that. But in general, I've got 3. Head is the top of the tree, or just kind of where the remote pointer is. But in general, we're not working off head, we're working off a branch reference, and head just kind of comes along for free, so let's not get too caught up on that. And by convention, the main branch is always called main. So what this tells me just by looking is that my local copy master branch is 1 commit ahead of origin/master. And origin is the default name of where I cloned this repo from originally. Okay? But remember, we talked about 3 different places. Original, fork, clone. Okay? So what were to happen? Let's work on this theory for a moment. We're going to have to be really careful that I don't get out of sync too bad. So this is the main copy on the main repo. So I'm just going to change the version number on the main repo. And I'm going to commit and push that. Now, again, I could do this graphically, but just to demonstrate that we can do all of this in 2 places. There we go. Okay. And I'm using OMyZSH as my shell, and I have a plugin that hooks into Git. So it tells me I'm on the master branch, and that little red X says that I have uncommitted changes. That somehow my working directory is dirty. Not everything has been committed. So if I say git status, it's going to tell me the same thing that the branch did. It actually tells me I have 2 files changed. I don't even know what. This was us messing around in class last time, is what was on here. So I don't really want to push the hello world. But let's just push the version change. So git add package.json, git commit, -m is the message. If I don't do that, it's going to open my default editor, which in my shell is vi, and this is we're going to use. So let's just go here. The version number for demo purposes. Okay. Keep in mind what you saw in source tree. Same thing happened here. Original, fork, clone. This is a clone from the original, so now we technically have 4 copies at play here. Okay? So I'm going to push this back to the original. And I want you to keep this in your head because this is how modern workflow works. Everyone has their own copy. And we all have to work to keep them in sync. So I'm going to push this up to the main repo. And you notice I still have unstaged changes. All I pushed was what I had committed. That's all that went up. What I hadn't committed stayed put. So if we go back over here to the original, we now see I have 2 commits. Okay? This also happens all the time. So now we're in all kinds of out of sync lanes. How do we make everything consistent? How do we make everything sync? It is super good at that. You just have to keep this minimum on your head. So this is why I keep repository. We have the original, the fork, the clone, and the original clone. So we had the 4. So I pushed up to here, and I have a change over here that I haven't pushed. So the easiest way would be for me to locally on my clone get everything consistent before I pushed it back up to my fork on GitHub. But to do that, this one doesn't know anything about that original. So we need to tell it. Other than cloning, this clone URL can be used to add a remote. And so this knows about one remote origin where I originally cloned it from, but let's tell about another one. So I can go repository settings remotes. I can do this from the command line too. It's just easier here. And by convention, we're going to name this upstream. And I'm just going to paste in the clone URL. Okay. Okay. And you notice over here in remotes, I have origin and upstream. Now I need to hit fetch. What this does is says, go find out where all the pointers are on all the remotes. And you notice all of a sudden, a new one came in. I have upstream map. and it's at a different place. Okay? So now we have all the information to get everything back in sync. So I'm on my local master. It's the one without a remote on it. It says one ahead, but this one's over here. And I need to, the first thing I want to do is merge my changes together so that the trees join. That's the only way they have to get merged at some point. So I'm going to merge. I just right click on that and hit merge. Again, this is why a graphical client is so nice, because it's really clear what I want to do. Are you sure you want to merge into your current branch? Commit merge changes immediately. Okay. And if no conflicts were created by that, then it just happened. And I have a new merge commit there. And so if I look at this merge commit, then I can see that my version bump was what came in. And that was the only change on that. I have one file that had one change in it. So now locally, I have a merge change of everything. So again, up here, we had our 4. I pushed over here. I had changes over here. Now I've sucked down and got this one up. Now we want to go get everything back in sync. Okay? So I've merged. Now I can start pushing my data up. So I'm just going to push. One note, by default, I'm going to be pushing to the origin repo. This is the one that I, in theory, have write access to. So this is the one I want to push to. I could also attempt to push to upstream. Now, I technically do have rights to push there, but in most cases I wouldn't. I would only be able to read from there. So I'm going to push it to origin, and I'm going to push the local branch to the remote branch, both named master. Normally, that's the way you want things. Everything matches up names, and things are going to auto-select because you have the default. But I could have named my local branch something funky and pushed it to any other branch name. There's nothing magic about this. Just by convention, match things up for your own sanity. Okay. Okay, I have now pushed. So if I go back to my web browser, and if I go to my fork, oh look, someone else forked it. So now I'm in the fork, and it even tells me right here, I am 2 commits ahead of my upstream master. So let's just say, okay, great, new pull request. And it automatically, by convention, figured out everything. So it's saying from Chad Killingsworth / Webpack Starter template on the master branch, we want to issue a pull request to merge back in to the Missouri State CSC 515 Spring 2018 organization Webpack Starter template repo master. Basically, we want to synchronize all this together. So let's just say create pull request. Title. Add some comments. So this is not the commit message. This is my chance to explain to the upstream owners again. So at this point, if you owned that upstream repo, you have no real idea about what's getting ready to come. So if you want, and I, as the upstream owner, have no obligation to merge this. I might disagree with what you're doing. I might think you use too many commas. I might, whatever. I don't like you. I don't have to merge it. That's to explain why I should merge it. So be nice. Don't be arrogant. Don't, you had a mistake, I fixed it. Also, don't be overly verbose. Don't, flattery just annoys. So be nice and polite. And then offer to say, hey, and then self-identify areas that you don't think are great. So you might say, hey, this is the only way I could find out to do this. I think it's a little bit messy. I'm open to exploring other opportunities. A lot of people just make a pull request and then just run, and you'll never see them again. And so if you want changes, it'll just sit there forever, and eventually you say, you know what, if you're not interested in the work, close it. So basically, make sure that the person understands you're willing to change it to make it, as long as you can accomplish your goal, you're willing to make it match whatever style guides or coding standards or methodologies they think of. So that's what you do here. It says, coming soon, we may have more than one Webpack config. Just preemptively noting that this is the main config file. And I probably didn't spell that right. Close enough. Create pull request. Boom! Your organization owners just got an email. And you notice I changed repos. I'm now on the main repo, and I have a pull request. So if we go over here, there's a pull request 1. Add some comments. Here it is, and commits. And I can go files change and see exactly what's going on. Oh, look, they're just adding 2 comments. No big deal. And so a conversation can happen here. I could say, looks good, or hey, can you put an extra line break between these 2? Stylistically, I think it looks better. I can do all kinds of things, and we can go through that whole dance, making commits, merging, pulling, all of that we just did. But in this case, I'm going to say merge pull request. This is my favorite kind. No conversation. I liked your change. I'm just merging it. I see you. Okay, there we go. So now if we go look at the Webpack server, I'm up to 5 commits. Initial. And you notice the order. And it's 5 times. So notice I made my change and committed it in that other copy. But later the version number got bumped. Remember the order I did do it. So by date and time, it's going to order them. Then you can see they were merged, and then I merged the pull request. So let's go back to a source tree and look at the state of the world. Nothing's changed. Why not? I need to fetch. Tell it to go look. Now, some of the source tree is going to sit here, and if I haven't done anything in 10 minutes, it's automatically going to fetch it for me, kind of behind the scenes. But I can always say fetch. Okay, upstream master is ahead. I want everything the same. I want to get everything consistent. So all I have to do is pull. But if I pull origin master, it was already there. Nothing happened. So remember, original, fork, clone. And I push changes up, and over here was merge. Okay, so I need to pull over here, down, and then push up here. That's the only, I can't pull directly to my fork. I have to pull it to a local copy and then push it back. That's the only way I can get everything in sync. So when I pull, I don't have to pull from origin. I can pull from upstream, but then I have to select the branch because I just, so upstream master pull, and by pulling I mean bring those commits into my master branch. Okay, here we go. Boom. Now upstream master and my master in the same place, and it says 1 ahead. And notice push has a badge on it. If I just hit push, origin, master, master, okay. Ta-da! Now we're all back in sync. This concept, most of you guys have seen Git before, so this concept, though, is probably a little bit more than most of you have done before. Everyone okay with this? Questions on this? How this all works? Okay, good. All right. This gets a little much for people to do on a regular basis. And we may want to get to here by the end of the semester, but to start with, we're not going to be quite this complicated. I'm going to create, each and every one of you, your own private GitHub repo for every homework assignment. 4 or 5 of them, so you're going to have a private GitHub repo. You're going to have push access to that repo, so you don't have to fork it. And if you want, you don't have to. However, there's one tiny tidbit. You will not be able to push or merge into the master branch. Because I'm going to do that as saying, hey, I've accepted your homework assignment. Okay, so that's, and by the way, the deadline for a submission for homework is going to be either the last commit date or when you open the pull request. And why I say that, you can commit all day long, but if you didn't open a pull request, I don't know that it exists. You can open a pull request the first day and then just keep adding commits to that open pull request. So if the deadline's Friday at midnight and at 11:58 on Friday you open a pull request for 3 commits, great. But then 20 minutes later you push a commit, that's after the deadline. So you see what I'm saying? So I would penalize you for that unless you told me, hey, that was a screw up or I was messing around, grade it from, and you can do that. You can email me and say, grade it from this commit, and I can do that. Or you can say, no, I want to take the penalty because it's actually fixed it. Okay, so you weigh, but that's what I'm going to take. So you have to open the pull request and you have to have commits there before the deadline. But because you can't push to master, you want to do all your work from a branch. So when you clone the repository down, the first thing you do is make a branch that says my work or local copy or homework 1 or doesn't matter what you name it. And then you're always going to push to that branch. And that branch isn't going to exist the first time. You have to push to a new branch. You got this? Okay. So I will, every time there's open homework assignments, I'll start class. Any questions on homework? And I literally mean any. Can't figure out this Git thing. Weird Webpack error. NPM's freaking out on me. All of these things are totally fine. Please don't sit there and not ask questions. I would much rather you ask the question. Chances are 4 other people have the same problem. Not necessarily just something stupid on your part. Or it may be something really simple, but you're never going to find the answer without asking. So I would just prefer you ask. Okay, questions? Again, you don't have to fork, clone and make a branch and then push to a branch. The nice thing is when you push to a branch, we didn't see it because we were on master, but when you go visit the web page, GitHub's going to add this big yellow banner that says you recently pushed to this branch. Do you want to make a pull request? New pull request right there. If it's been a while since you pushed the branch and you haven't opened the pull request, you may have to come down here and hit this, like the branches for you. I recommend on your first homework assignment that you open the pull request sooner rather than later. Like, you don't have to wait till you're done. So you can clone it down, make a branch, push the branch up, open a pull request, no changes. Actually, I think you have to have at least 1 commit on there. But you can do that right away. The other thing is if you have questions on your code, pull request is a really good way to ask. Because when you create a pull request, I can go see all your code and I can go comment on that line. Like, remember I was saying things about stylistically? Even after the fact, I could comment. I really would have preferred an extra line separating. So it's really easy because I can add context. I can add on your code and you can respond and you can ask questions. So pull request doesn't mean you're turning in the assignment. I'm not going to grade it early, but it is a chance for you to ask questions. So that's also a really good thing. And a lot of dialogue happens on GitHub in that way. So utilize a pull request. In fact, if you email me a question, I'm 9 times out of 10, you have code I can see. You open a pull request. And you can put work in progress on it, not done, whatever you want, makes you feel better. It's the way you have it. Any other questions? We're over time. All right. See everyone on Monday.